That was the wrong button. Hello. It's been a bit. So, if you're somebody who's actually watching the VODs, I guess I can give a quick update on where things are since last time. Basically, have gone a complete 180 on all the identifier stuff that we've been doing in order to support this concatenation syntax for snippets. My initial solution for that was to break up identifiers into these chunks in a linked list, and then CodeGen or whoever wanted to later can then reconstruct the full name by traversing the list. It was working. I was getting it like little by little on each of our types here. Decals and expressions, you know, variable, all these different things that have names. Every one of these names had to turn into a linked list, including anything I wanted concatenated, so types and anything like that. And it severely complicated the parser in about every single place it could possibly complicate it. And from the very start, I didn't like it. I didn't like what it was doing to the code. I didn't like what it was doing to understanding how the parser was working, how the CodeGen was working. I just really didn't like it the entire time. And finally, I hit a point where I'm like, you know what? I need to trust that feeling. So I spent like 3 weeks to a month dismantling all of that and basically getting back to what I had before, where these are all just strings, which we're back to now. And I turned on a bunch of metaprogramming stuff that I'd turned off trying to get that stuff to work before. So you can see here, I have some stuff printing out. So if we look, one is a function that takes an any, one is another function that takes an ellipseed any, right? I had in here a templated struct as well, just to test that that was working, and all that stuff is working now. Again, none of that broke. And thankfully, in the process of setting up that identifier system, in the process of doing that, a lot of the parser logic had to get a lot more robust and a lot more serious. So even though I stripped out all the identifier stuff, I got to keep those improvements to the parsing logic in a lot of places. So we're in a better spot. The parser is smarter and more robust and is doing things better than it was before. It's just that we are, in some respects, it was wasted time. I mean, it really wasn't, but none of that stuff is going to be there going forward. So what are we going to do? We're going to keep it as strings like this, but instead we will basically, what I'm planning on doing is this whole thing will be a single token. That will be the whole name. That will be what will be inside this short string. So I'm just storing the whole thing, and I will flag that node to say, hey, this is concatenated. Because when I parse that, I'll be able to detect that that's a concatenated node. So I'll just flag it that way. I'll flag it as such. And then the code that turns this snippet into actual source at the call site, it can handle the concatenation part just at that point, right? So yeah, that's where we're at. And right now, none of that works at all. So we're pretty much starting from scratch again on the concatenation stuff, but that's fine because I think it'll be a lot better. So here's like the last vestige of stuff from that previous work, where I can tell if a token is last in a sequence of concatable tokens. So like in this case, normally when I'm parsing, it's like, oh, type, identifier, concat node, equal sign, whatever. There are cases where you could have two identifiers back to back. So like say the type was also concatenated, right? I would have to know like where, I'd have to know there was a space in here, right? Because this could be any number of tokens. So I would have to know, hey, okay, I'm parsing a name. Well, there are no tokens space, right? So they're just a stream of tokens. This would be a token identifier, token concat, token identifier, token concat. I would have to know there was a break in here. So I just tag this one as, hey, this is last. This one's not. This one's also last. So it gives the parser a way to know where stuff is. So I'm trying to think if I even need that anymore. Because I guess the first decision I have to make is the Lexer is designed to be really dumb and lazy. It just eats and chews through tokens. That's all it does. And if I remember right, even it is kind of the longest part of this process already. Oops. This doesn't work yet. Yeah, so you can see parsing the nodes takes like lexing takes about 7 times, 8 times slower than it does the parsing part, which is interesting. And the reason these numbers are so big, actually, like even though the metaprogram is doing like nothing right now, it's because we're not in release mode. So normally when you would run this, the compiling step for the metaprogram takes a little longer, but that's because we want the metaprogram to be in release mode. And then yeah, so you know the lexing takes 1/4 of a millisecond, parsing takes 3% of a millisecond, and then the actual metaprogram itself takes 100 milliseconds. And this is doing, well, what counts as the metaprogram is all of the lexing, or all of the built-in metaprograms, the stuff you write as metaprograms, all of the templating, all of the, yeah, it's a bunch of different stuff right now. So anyway, that was a lot of preamble. I need to probably break this down at some point and really see where our time is being spent mostly, to see if there's stuff I can clean up that's not strictly metaprogram stuff. But anyway, to get back to where we were going, I have to decide if I complicate the Lexer with more specific things, like how to interpret these concat nodes, or if it can just keep spitting out lazily all the tokens, and maybe the parser has an extra pass that goes through and combines the concat tokens, which I kind of think I like more. Because parsing is already so fast that, and Lexer is already not having to care about that. It doesn't really need to know all that stuff, so yeah, let's start doing that. So I guess I still need this. I need to know when the token concat or an identifier was the last one, I guess. Which I'm already actually doing. I'm already flagging them still. So maybe this is actually still fine. Let me do parse. Let's every time we get a token, let's do peak token. Peak token index, I guess. Let's just write out let's do this. If this flags, is it just flags? Is it token flags? Flags. If flags and token flag last, let's just print it out. Print token that. And sure, be verbose, I don't care. This is a dot. Cool, okay. Do we see, like, we should see, for example, this F, this X, and this equals on line 185. Let's search for 185. Right? Here they are. So every time we peek a token, right now I'm just seeing if we see any ones that are last, and we do see them, right? Something that shouldn't show up, for example, is, well, there's a lot of stuff that's not showing up, but like this whole thing should show up. Typedef is the last one, then unsigned, then int, then u8, because it's really counting where spaces are. Yes, like this plus plus shouldn't show up on line 193. Oh, in fact, the X doesn't show up either, right? The last thing on this line, because there's no spaces in here, is this semicolon. So that's working, right? Cool. So that part already works. I can already just cross that part off our list here. So now we need to, you know what, I didn't actually test that tags are still working. I'm gonna put a to do in there for that. Okay. String concat. This is the preproc, like the C preproc concat, so that's not. Okay, so I guess let's just start with identifiers. How do we want to do this? Oh wait, no, you know what? I said I wanted to do this in a pre-pass on the parser, so parse lexer. Run a pre-pass to combine concat nodes to combine concat nodes, I guess. I guess we'll just say that. So concat node pre-pass on this lexer. Do we need the parser? I don't know if we do, but I'll pass it anyway. Concat node pre-pass. And you know what? How about we, well, it can just exit the parser early if it has a problem, I guess. Yeah, that's fine. Okay, it takes a parser and a lexer. Now, let's
say for token index is less than lexer num tokens. Okay, for now, let's just print out all the tokens that have this flag on it for now, shall we? Token is lexer tokens can't type tonight. If token and token flags and we might as well be verbose. Okay. So we should have the same output we did before, right? What did we have? Like 185. And unlike before, we were getting a whole bunch of them because we were calling it on peak. Now we're just looking at the tokens that have it, so we're only seeing one of each. So we're finding them. That's step one. But now I need to go backwards until I hit the first one, right? Well, I need to go backwards until I hit the last one, and then just exclude that, right? I guess. Ooh, no, that's kind of gross, actually. I almost wonder if the lexer should be taking care of this. Because the lexer is already in context. It already knows that it's parsing an identifier or something. And if the next thing it sees... Yeah, I feel like the lexer really should be doing this. This is feeling very gross to me, and I need to start listening to that part of me that says, hey, this is gross. Don't do this. So maybe we don't need this flag for last anymore. So let's see. If I just search identifier here, if I say add token, yeah. So let's say add token. Do we add tokens anywhere that aren't this function? That's lazy lex. Oh yeah, we do, because we have things for individual. Okay. Okay. Let's just start at identifiers. Ooh. Okay, actually, peak until non-identifier character. Could we just have this include the concat part? Peak concat directive parts. I don't know. And we'll also include the length. So Um, so is white space. So if it's not white space or a new line, do what? No. White space, new line, and it's either alphanumeric or an underscore. So can I say let's do this. Let's take all this, regular identifier. So there's that. While regular identifier or peak concat directive parts. And we'll pass the cursor and our length. So this is going character by character, right? And since peak concat directive parts advances length in a chunk on its own, while this loop just does one character at a time based on the identifier characters. So we only advance if it's us, the loop. Sure. There's a little bit of a goofy loop, but that's fine. So as long as the next thing is a regular identifier character, or this thing has skipped ahead for us, we'll keep trying. If it was just a regular identifier character, we'll just skip forward by one. This thing, though, will skip us ahead even more. Right? So yeah, that's fine. This could be cleaner. Like this could maybe just tell us how many to skip. This tells us to skip one. This tells us how many to skip, but it's fine for now. It's whatever. Okay. So we are going to grab the peak cursor will be this, and we can say next C. If not, so if next C is not equal to this, then we can just return. Because it didn't find anything to do, so it just said, hey, there are no concat directives ahead of us. Okay. And then okay. We can say plus plus length, so we can increment that. Then if do we have peak character index? Dynamic string. We do. Okay. So now we can say if peak character index peak cursor we'll advance this as well. Advance, what is it? Skip characters? Skip characters. The peak cursor, just one, so we'll skip ahead of that, and then here we'll say peak cursor 0 equals C, and so we'll just check all these. Concat. Right? Otherwise, you know what? Actually, we don't need an otherwise. We'll just say return false. So that's 1, 2, 3, 4, 5, 6, 7. If that's true, then length plus equals 7. We will skip 7 characters. You know what? This logic does make more sense for this to return how many characters to skip. It just straight up makes more sense. So concat characters will be that. So if this or this, if that, then that, else length plus equals concat characters. There. So this will be 0. This will be 0, which also counts as false. So it won't count for this if it didn't find anything to skip. And now we don't have to modify this until the very end. In here. So result is 0. Actually, we can do that in here. Or no. Here. Okay, so result is 0. We skip 1. Plus plus result. Here we skip 1. We skip 7. And result plus equals 7. The only problem with this is I don't know how to catch syntax errors here. Because what if there's no... Do we do errors in here at all? I guess we do. The Lexer can report errors like this. Malformed comments. Okay, yeah. It doesn't report much, but I guess anything that has to do with text, it can report, and
these concat nodes in the snippets are text, so I guess that's okay. I guess that's fine. So now need to skip whatever is inside here until we hit the closing parent. And we can do that by we need to call peek until non-identifier character again. Right? But that's not really set up to do this. Oh, I guess it is. Because we're passing we can pass it the peek cursor. Okay, this might actually be fine. So let's take this and give us a forward decal because of C++. Where do I even put this? I guess after the structs, whatever. Where are we? Directive parts. Okay. So now we can say we don't care about what the result is. Peek until non-identifier care. Well, I guess we do because we have to skip over the length of it. So inside equals this. And then we can skip characters this thing's length. And then result plus equals this thing's length. Okay. And now we expect, do we have an expect in the, no, we don't. So we'll have an error in token concat. How about that? And now we say, wait, peek character. This should be in the peek cursor. So now, if peek, how about this? Instead of this, since we're not actually using this for anything else, we'll just do this. If peek character, peek cursor does not equal a closing parent, this will be an error. Token concat. And we can return 0. Otherwise, we could return results. After we skip again and do that. Yeah? Does that seem kosher? Lexer was not declared. Correct. We have to pass the Lexer in here. Which means this needs the Lexer, which is a little bit annoying. I mean, I guess that's fine. It's a little annoying that it needs the Lexer, but it now needs context. It doesn't have this anymore. Oh shit, all that stuff needs the Lexer, huh? Crap. How many places call this?
I guess not that many. Let's just go through. This takes the lexer. This should take the lexer. That takes the lexer. This should take the lexer. That already has the lexer. This has the lexer. Okay, that's not so bad. These can take the lexer. Okay, that's not so bad. Forgot a comma. That now takes the lexer. We crash. Or we just infinite loop somewhere. Okay, that's oh, I didn't do this again. Oh, because I have to I need to rerun this every time. So if all that or this. Okay. Regular identifier is no longer a thing. So if we'll say concat characters is 0, and this will be concat characters equals that. So if this is false, right? So if we say not this, so if this is false, the only way we'd get here is if all this is true. If this is not false, then we do this. I think that's fine. That logic works. Makes sense to me. Oh boy. What did I do? Or does that not work? Oh. We compiled. Okay. That's great. That's fantastic. I do feel like the metaprogram is running really slow. And I don't know why. Is it really these that are causing it to be so slow? It is. Which I guess makes sense. I'm also in debug mode, so that doesn't make it take very long. That doesn't make it take very long. Function templates cause a bit of a pause. Type infos take a long time. Which is this. Yeah, see, I need to just go through and time this stuff and figure out why this stuff takes so long. I mean, to be fair, like this is looping through every single struct in the entire program. you know, it's looping through every type def, every struct. And generating a bunch of code for it. So I don't know. These loops, these macros, are kind of gross right now. They can probably be very sped up, but it's okay. Let's not get sidetracked. Okay. So that's good, I think, as long as we are properly skipping those now and including them in the tokens. So theoretically, I can include this. You know what? Let's do a super simple one. And just say int x underscore concat val equals 5. Theoretically, this should be 4 tokens. Int x underscore concat val equals 5 semicolon. So 6 tokens. Okay, well that clearly didn't work because it got the x by itself. So let's break into the lexer and see what it's doing. Parts. Okay, let's go here. And we're gonna be on line 180. Lexer running line number equals 180, or I guess that's right. I don't remember if the lexer starts at 0 or not. 180 next C is I. That makes sense. Okay, I think we're good. All right. Length equals 1. Why does length equal 1? Why am I starting length at 1? Oh. Because I've already skipped the first one. Okay. Interesting. Okay. Concat characters is 0, right? Because I'm just passing I. And then it should be... man, I can't look at that token right now because it's... That should have been an N. This should be a T. Let's just look, shall we? Result data length C. Okay, where are we? That's not right at all. IN C. Oh, we're at the include. What? We're on an include. Oh, running line. That's why. Not running line number. It's running line. Okay, so I think we do start at 0, so this should be 179. That's frustrating, but it's okay. All right. I N T. So now we should see a space. Right, so we're good there. We're done. We got the int. Now we should see... Wait, what? I 179 column 4. We're back at the start. What? What? Why are we doing it again? So this is int. I am so confused right now. I in. Let's do this. 0. Oh, they make this so hard. Arg. And this should say C. Or, yeah, okay. So. And right now, what is length? Let's always look at length. So length is 1, so we're right here. 2, 3. So we're done. And next should be the word int, which it is. So wait, what? Grab full fundamental type. Oh, we just do that a second time. That's stupid. Yeah, we grab... I guess that was just determining what type we were, and then we hand it off to another function that does it. That's stupid. So if we go again... There we go. Okay, that's why. That's why we were hitting it twice. So now we're at the right place. X underscore concat, right? So how about we do this? Length. And then we'll say length plus. So now we can see this move. It'll be like rolling through the characters. Arg. Right. And in fact, why don't we just do more of these? Nope, not 8. Okay. So there's concat, right? So, well, once again, we'll print length just to make sure that we know what we're doing. So, we see the X, we ate it right up there. We see the underscore, we skip it. Now we should see concat, right? We see the concat character. This should return us 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This should be giving us a 12 back. Oh. It didn't do anything. It just didn't find it. So that's a problem. So let's jump into here specifically now. Okay, peak cursor. Is that include? We don't care about that. Include external int right. We want this to say you know what? Let's go here. Or let's go here and say Lexer running line equals 179. There we go. Okay. Int concat x. Wait, int? What?
Oh, shit. This is not correct. We're passing in the original cursor before we're moving forward through it. We need a peek ahead cursor there. We need a peek ahead cursor here. So wait, no we don't, because that's already eating through them. Hold on. I might have been jumping the gun again. Holy crap. Because we're only hitting this because... Yeah. The outer loop does eat that, okay? This eats the int, but it is hitting this. Anyway, okay. So now we're here. We skip the X. Underscore. There we go. Wait. Why did we also skip... Why did we also skip the pound sign? Why did we skip the pound sign? That shouldn't happen. Okay. So. Wait, what? What is happening? X underscore concat. So we skip. What? What? Okay, well here's one modification I need to make is this check here needs to be this needs to be ORed in with this thing, not that thing. So that's one thing. I don't think that helps us, but what did we say this was? 180. It's 179. Okay. Next C is the I. Okay. So that's int. We got int. Okay. Now, X. So we should, this function should be grabbing this whole thing as a single identifier. That's what its job is right now. Starts identifier. So that's a problem because it could start with a concat token. I gotta remember that. So starts identifier. I don't know if this causes any extra problems for us, but later on down the line. Anyway. Okay, great. So here we go. We're at the X. The next character is an X, so we have looked at the X, and now we should be looking at the underscore, which is this, right? So we shouldn't even go into here. Right? So we didn't. We skipped the underscore. And now we should see the pound sign. So we should go in there, which we do. Peak character should be the pound sign. No, it's not, because we didn't skip over the X. The X underscore. We do need a peak cursor here. We just do. We need a peak cursor. Straight up. So we peak a character, and we'll just use the peak cursor here for consistency. Right? If it doesn't start an identifier, you know what? We'll do it this way. We'll simplify this too. If not starts identifier, peak character, peak cursor, then there you go. Otherwise, we will skip characters on the peak cursor 1. Then we can put that back to 0 now. Is white space peak character or peak cursor, peak cursor, peak cursor, peak cursor, and this can take the peak cursor, right? Yeah. Okay, well, we have a different error this time, so that's at least something. Why are we not... Hello? Hello? Give me the breakpoint. Thank you. That's 179. Why are we not hitting this? Why are we not hitting this? $180, it's right there. I must have broken something. Okay. What is result now? We are seeing... Whoa. Okay, yeah, I broke something doing that. Make cursor. Make cursor. Oh, we do need the length to be 1 there. Oh, this function is written very poorly. Peak until non-identifier. Okay, let's make this a little bit nicer. So peak cursor. Then we skip the first one. So length is 1. Okay, this needs to just be peak character on the cursor. Forget the length here. Peak character, that's what I did wrong. So now we can keep track of the length still for the result, but I shouldn't be calling this so many times. I need to be storing this. Oh, which in fact we can now, right? We can say that. So this can be peak C, peak C, peak C, peak C, and then this, if we only incremented by 1, we skip 1 character. Otherwise, we skip this many. Okay. Okay. That is a problem. We are pulling some crazy weird stuff now. We're at the include, right? So this should be an I, which it does. So we skip that, right? Peak cursor's there. Peak C is an N, while length is less than peak cursor.length, which is fine. Oh, I didn't set peak C. You gotta set peak C. If you don't set peak C, it's gonna just freak out. Okay. We are cutting stuff off now. Num any pa got rams. Interesting. This is cutting stuff off now, which is a little funny. Okay, let's see. Peak C. Okay. Skip it. Peak C is now a C. Great. So where's num any params? Where are we getting that from? Num any, right there. So we broke on this for some reason. So let's see how we handled our line 180, shall we? How did we handle that? How did we do? Lexer running line is 179. Okay. Here we go. Int x concat. We should... Let's jump down to here. So we stopped at the space. Result is the word int. Great. There we go again. we're at oh, we're doing it again. Duh. There. Okay, X concat. Here we go. Peak cursor should be an X. Great. Peak C is the underscore because we saw the X already. Great. Oh, but we can't skip. Why do we do that? We can't skip if it starts with a concat because then we miss the pound sign. So why do we do this stupid thing? Why do we skip over immediately? Or why do we skip it though? So if it starts an if it doesn't start an identifier, boom. That's fine. We don't have to skip over it. Just start now from there. Yeah? Just start from there and just go. Well, we're now segfaulting for some reason. Let's see. Int, boom. It does start an identifier. So what do we get at the end of this? Is it int? Result. Yes, it's int. And then int. And now we're at the X part. So C should be an X, and it is. So we skip ahead. We see an underscore, we should skip ahead. We see a pound sign, so we should go into here. Do we have a breakpoint set? We don't. There we go, we're in here. Peak character should be the pound sign. It is. So we skip ahead and we count it. Now we check, is it the rest going to be concat, open, boom. Great, so we skip over those 7 and add them onto there. Now we peek again because we want to peek on the inside here, right? Let's break out of that real quick. Damn it. Org. Okay, hold on. I need to get rid of that breakpoint at that point. Okay, we'll go here. Go on through. Turn this off. Turn this off. Okay. Now, when we grab this, that inside should be the word val. Which it is. Length 3 val. Great. Skip over it. We skip past it. We add that to our length. The next thing should be an open paren. It is. Skip it. Add it to our length. Done. Concat characters is 12. We should skip over all these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Great. Boom. We skip past it. We hit a space now. We're done. Cool. That should have skipped past it, which means the identifier that we added, it thinks it's a fundamental type, but I need to get rid of this concept of fundamental types, honestly, but haven't done that yet. So add token short, fundamental type, the type we're adding is, oh, int. We didn't grab that correctly. Oh, why didn't we? I thought we just did that. Grab full fundamental type. Okay, what happened? Interesting. Okay. Let's do that again. Okay. We'll break out of, and we'll just go break out of this. It's fine. Oh, no, that was fine. I'm messing up. Okay, hold on. Result. Result length is 3. Here it is. So, we return this whole thing. Great. Grab full fundamental type. Wait, why did we think that was a fundamental type? So what is result here? Result is int space and we... So that's the int part. I'm so confused. Now we're doing this again. Maybe that's why the Lexer's taking so long. I don't understand why we just went through all that if all we're doing is grabbing the type. That doesn't make any sense to me. Why are we doing that twice? Or why are we doing that at all if we're just grabbing the... Let's do this. Fundamental type. Let's do this. And this will be online. This. Okay, where did we come from? Lazy Lex. The cursor is right here. We should just grab int and then stop. I don't know why we keep going, or why we go on to do all that other stuff. So we go in here. Peek until non-identifier character. That should just give us... Oh, that's why we peek until we grab int, and then this. So next is int. It starts a fundamental type, and now next is this whole thing, and it doesn't. So we're done. That's why. Okay. That makes more sense now. Okay, I'm cool with that. Honestly, I feel like we can early exit even more than that, or even sooner than that, but that's okay. Let's go back to here. No, we'll go here. Cursor. Here we go. Okay. Let's go back. Shit. I'm gonna go down to Lazy Lex. And go until we're at line 179. And I'm gonna wait until we're at there. So we're at the space after that. So, in here. When we grab result, it should be that whole thing. What? What? Cursor is I am confused. How come we don't see this part with int? We don't see it. X. How did we do? Oh, that's probably because at that point, lazy Lex probably skips the new line first. If this is 178. Yeah, so here, there's a new line and then int. Hello? Why? What? Then it just doesn't go? I'm so confused. Oh, I am... It's been a day, okay? It's been a day. So as soon as we hit where this new line is going to be, boom, I get rid of this now. Now it's just a normal breakpoint. No? Why? Why though? But why though? Okay, simple, val, space. Okay, let's go in here. Skip white space and new lines. There, that's what I was expecting to see. And I don't know why this is freezing when we do this. There, we grabbed it. Great. Wait, what? Now it just... Oh, that must be where we're seg faulting. Okay, okay, that actually helps figure out what's happening now. That's where we're seg faulting. Go through here. We grab int. Boom. If lexer next, which we don't have one, that looks like I'm stomping over memory somehow. I don't know how that could be the case, but it looks like I am. Where am I stomping over the memory? How am I stomping over the memory? So it's null, right? Cursor length and not lexer error. No error. The cursor has plenty of length left. This call is crashing us. Just checking this is crashing us. Lexer. Like, even Visual Studio is still running, but clearly the program is crashing there. I didn't think this part was going to take this long, but it is good in that if the Lexer can just handle this, this is not a lot of code to be changing in the Lexer to support this, which is good, but what if we remove this? No, we're still segfaulting. What if we remove this entirely? No. Okay, if we do remove this entirely, where are we crashing? Just immediately? No, not immediately. At a certain point into the file, we just crash. And it happens to be right here. What did I do? And how did I do it? Could it be this? Should I not be interpreting that as a... No, that's too easy. What if I remove this part? No, we still crash. Okay. Whoa. What the hell? We are getting a bunch of nonsense. I am doing something really stupid, clearly. I just have to figure out what it is. Because we just get a bunch of nonsense in the output and then we crash. Okay, let's go back to this. Just look at result. Result. And let's go until Lexer running line equals 178. Oh. Okay, we just... Oh, that's why this isn't stopping. We're not seg-faulting in Visual Studio. We are outside of Visual Studio. But in Visual Studio, we just keep going. That's good to know. Pause. Can we pause? No? Okay, what about 170? We already break. What about 160? Dude, what is happening? Here, how about we do this? How about we run and immediately stop? Can I see where we... Wait, we're still... What? I stopped you. Hello? Okay, I'm closing Visual Studio real quick. Trying to see what the hell's happening. Boom. Okay, let's go even further back. How about just 60? Really? How about 10? Dude. Genuinely, actually, what is happening? Include external int, right, int, care, int. Line 33 is where we're at right now. External, int. External. This is line 34. The external on line 34. Right here. Void. Oh no, we're here. Printf is what should be next. Printf. Care. Int. Snippet testing. Three, okay. Ooh, okay. Write it after the F. Okay, let's see why. We're stuck on that for some reason. So we see the $, and we go in here, $F. peak character. Oh. That's why. Starts identifier, or is there a continues identifier? Continues hex. That's why I had a special case for the start, was because certain things can start identifiers but not continue them. Oh boy. That's why. So I handle that here. If it doesn't start an identifier, we're just done. So this can just also be I need a continues identifier, right? And that's all this stuff. This is alphanumeric, C, or all this stuff. Not that, though, because we handle that separate. Hey, look. So now we're breaking on this thing, same as we were before. We aren't here, though. That's weird. That's really weird, actually. Okay, let's get rid of that. Why is that happening? Can I, like, I want to print the token here, which I already have a thing for. Here we go. So, unsigned int, num any pa rams. It's splitting those up for some reason. And it's in the primary chunk. So, primary chunk. And the primary chunk is where all the initial metaprogram output goes. So I want to see this. Generate source file for chunk. Oh, that's not gonna work. I want to print its tree is what I want. So here, after this, I want to print AST primary chunk. And let's not print the tokens anymore. Oh no, that's in parsing. It doesn't even finish parsing. Wait. Yeah, it stops in there. The output source, the input in this case is parser AST. So here's what we're inputting into it. And there's no so it's right there. This, it can't figure this out. So when it goes to decipher this, so when we do this, yeah, those are bad error messages. Okay. Is it the default metaprogram where the problem is? Yes. So, is it... Well, it's got to be the function templates, right? Because that's what we're generating there. Yeah. So, generate function templates. Can I print the AST here? It should be the same thing. There we go. So for each function call, so we're calling test2 here. And we're looking for the template. Okay, from here, let's print AST current.node. So here we go. We match test2. Let's just see where we're breaking in here, I guess. I'm just gonna drop a few more. Okay. A, B, C, D, E, F, G, H, I, J, K, L. I didn't even put it in all the places because I got lazy, but A, B, C, D, F, G, H, I, J, K, L, A, B, C, D, F, G. So H, after H. So after H, H, underscore b. Do we get to h underscore b? No. So, do we get here? Yes. So we break in here. Inside there, if we see something called num any params, before that we need to insert. Okay, let's just break there, shall we? Something strange is happening. Here. Function templates. So if we, the way this works is if inside of your function template, if you query this, which is a thing that we generate to tell you how many of these were passed, if and only if you query what this is, do we insert a decal variable into your function. If you never query this, we don't even generate one for you. So, done with this. Done with this. So here we go. Current node. Well, whatever. We know we find one eventually. Right? We do find one. So current node decal ref is called num any params 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There we go. Num any params. So insert before. Template body. Children 0. What is template body? It's a compound statement whose children are. The first is a decal variable called x, which is a u8. Right, we insert it right at the very top of the function, which that should be fine. Create simple variable decal node. The source is five. What? Type is const unsigned int num params. Oh, value is 5. Oh, because we made a cursor. Duh. Jeez. Okay. Type const unsigned int name num any params. Create simple variable decal node. Create string builder. Boom, boom, boom. Boom, 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 boom. Boom. Boom, boom. So the code in this case is right there. Const unsigned int num any params equals 5. Create source node from code. So in here, we go to lex this thing and we're not understanding it based on the changes we just made. Question is why? That's fine. Lex source code. This is what we want. So the peak character, the first thing should be the C for const. There it is. Constant. There. Here's what we're parsing, right? Or lexing in this case. This is the line we just inserted. I just realized this whole stream I have not been streaming at the right resolution. I'm a goober. Well, that sucks. I guess I'll put a disclaimer up at the start of the VOD or something that I forgot to do that. Oopsie, it's been a while since I've streamed, so no one's been able to see anything. Nice. Good job, me. Well, fuck. That's cool. Oh well, it happens. This stream's gonna be a little hard to follow, so I won't let it happen again. Okay. Peak until not identifier. Next is const. Great. So now we're to unsigned int. Next is unsigned. So we should have a starts fundamental type, which it does. Okay, so we grabbed the whole thing, unsigned int, great. Cool. Now we see the n for... Oh. That was it right there. We didn't grab the whole thing. Well, alright then. Lexer running line is 2. Running column is, so we'll say, Lexer running line equals 2. And let's just start over. Get rid of this. Get rid of this. Here we go. Boom. Boom. Alright, let's see why. Did I just do something real stupid? Starts identifier. Peak C is n. While length is less than that. It's not white space, it's not a new line. And continues identifier, which it should. Yep. So this all goes until boom, 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 eat through it. Why? Oh, hold on. What is the cursor length? 13. Okay, hold on. Length is 7. That's why. Shit. That can't be peak cursor length. Because peak cursor length is getting shorter and shorter and shorter and shorter because we're eating through it. That's the whole point, is that we're eating through the peak cursor. Right? This needs to be the initial cursor's length. Wow, that was very, We're back to compiling. How fantastic is that? That was a long diatribe and run around, which I guess is okay because I wasn't streaming at the right size anyway. Yeah, that's fine. Okay, well, now if we look at our tokens, right, if we go back to where we started this whole thing, and go to the parser, add token, not the parser, Lexer, and go back to add token. If we print out the tokens now, and we look for any concat nodes, where do we have some of those? So there's main. We should be getting close to something. Oh wait, we don't have any. I turned them off. So let's turn the snippet on and verify we see that. X underscore val. So there's that, right? Let's turn this one back on with the concat node in it. Multiple of them, actually. Okay, so now the parser is now messed up. It doesn't understand 174. It doesn't understand this nonsense here, which is fine. It doesn't understand what that stuff is, which is fine. So now if we go to xval and go up a little bit, there we go. This single identifier now includes the entire concatenation directive, which is what we wanted. That's great. But although, why is the parser failing on that then? The parser should still parse the whole thing as an identifier. A little confused about that because it's just peeking tokens, right? Expected expression. Let's look at that really quick. And then I'll probably call it. I feel bad that this stream was basically unwatchable, but next time I will not forget to do that. Parse variable. And then plus, starting next time, now that this thing is done, even though this took me so long, the fun part's next. So next stream will be more exciting. Why are these off? Hello? This is supposed to be a monospace font. How is this off? Whatever. That doesn't make any sense. Right? That's so weird. Anyway. I think we get here. Yes. So, we are on... So why does it think this is a token preproc for val when we printed out all our tokens? What line is this? 174? Oh wait, we do see that. Oh, this. No, this is working fine. This is actually working. Oh my god. I was going to introduce other syntax into this. Right? In order to distinguish whether you're asking for the actual thing that was passed in or not, I didn't want you to have to just type like this and have it be unclear that you're asking for what was passed in. I want you to be explicit about it. So I was going to introduce this syntax. And I guess I forgot to put it in there, so it thinks that's a preproc. This is fine. It did this whole thing just fine. If I make this a 5... we work just fine. It parsed that just fine. Oops. Alright. Yeah. So... test... ref... val int x val equals val printf %I val x val. There we go. Okay. Now it doesn't know what this is, which is fine. I think I can make a new to-do. Parse this as a new node type, snippet value reference or something. At parse time, connect it to the corresponding param for easy replacement later. To do identifiers now, node names now include the full concat directive. Now it's up to the snippet code gen to figure out what has to happen. So before we do that, let's give the snippet some help for the future and say, where are my node flags? Node flags, here we go. We'll say node flag contains concat. This node's name contains concat directives. Okay, and then when we're parsing, I guess right now it's just identifiers. I guess. Maybe. Let's go over to the Lexer, and instead of last here, we're done with this. Instead of this, we'll say concat token text contains concat directive. Okay. And then in the parser, well, actually, let's set that first. Add token. Maybe we don't do that here. I don't really know where we want to do this. Concat, because here, peek until non-identifier character. It's really if this result contains that in it. So I'd have to go here and say all these locations that call it. I think what I need to do here, it's a little gross, is include a bool that says contains concat, right? And we can say concat
equals false. Concat. Oh wait, no. We don't care about that in this case. Here. If this then contains concat equals true. If contains concat, so you don't have to pass it, but if you do, or you don't have to give it a value, but if you do, then we want to set that. Grab macro identifier. I guess this also has to return contains concat. Grab full or grab fundamental type should also return this. This here, concat, here, we'll pass it concat, I guess. Which means if concat token flags or equals token flags concat. And you know what, for now, let's print out the token just so we can see it. Okay, let's keep going. Maybe concat equals false. Concat. Concat. Same thing here. Next. Oh boy. So all of these need it. And in fact, this needs it. This needs it. Concat. Oh god, this was all before I put proper punctuation on these. Okay, that's fine, that's fine, that's fine. Okay. So I'm definitely missing a lot of places here. This is gonna break pretty horribly. So let's just go to all the places where we add tokens. Add token. So here, character literal. This can just be false. String literal, false. Because right now we're only doing identifiers, which is a little bit lame, but we're gonna start here. Number false. 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 Comment. You're never concatenating comments. Processor parameters. Could you ever,
Would you ever still be using preprocessors? And would you ever use it inside a snippet where you want to concat them? I'm going to say no for now. That's fine. I feel like that could lead to some cool things, other than the fact that you already have snippets. You don't really need... The whole point was that I don't want C preprocessors. I don't want to be using them, so that's fine. Preprocessor body, add token. Did I miss any? I don't think so. False. Good. This is, what is this? Preprocessor directive? Okay, well I did it for that. This is the directive again. You know what? Let's just not do any of these. That's fine. False. 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 Like maybe we want to, yeah, I don't know. I wonder if I should just make that false by default. Maybe. I feel like that might be better. So all the places where I pass more stuff to it, you don't have to, but... Or you have to in those cases, but... Other than that... you can just omit it. If you want to add specific line numbers and stuff, you have to add it, but other than that, you don't. That's fine. Okay. So we add it to those, because those are identifiers. We add it to that, because it's part of an identifier. Those we don't care. Okay, that might be... Grab macro identifier. I forgot I added it to that. So grab macro identifier. That's fine. We can actually do it to that directly. Don't care in that case. 847. Oh, that's a peak. We don't care there. And grab full fundamental type. What is this for? This is for, no, we do care there, actually. Well, wait a minute. Yeah, we actually do care there. So we'll pass it concat again. There we go. So our concat directives here are, that's wrong. These are correct. That's not, though. Oh, because this is just for checking ahead. We don't care there. We only care when we go to do it. Right? Well, no, hold on. So no, we do care here, but for the fundamental type, the full type is we need another one. Type concat. It needs its own because if it sees it in the okay, why is that happening? Okay, why? In that case, why is let's just look, I guess. I'm here, might as well look. Where are we? We are in the Lexer. Starts fundamental type. Here we go. Line 174. Wait, wasn't it? Oh, right. I should probably fix that. It's only for debugging that you care about this, but it's always one off. Okay, type concat. So is concat true? It's not. After we go in this though, it is. So why is that? Grab full fundamental type. So next is int. Okay. Wait, what? What? How? So starts fundamental type next is int. It does. So boom, boom. Oh, we hit it here. Hey there. Working on a metaprogramming kind of language project thing. And right now, trying to support. I have these things called snippets that are basically macros in C, but they are parsed. They're not just like a textual replacement, they're actually parsed. And trying to get them to support concatenation. So if you pass in something in here, you should be able to concatenate it like you can in macros. So that's what's happening right now. You're catching me at the tail end of the stream, though. I've been going for a couple hours. And unlike my other streams, the first 2 hours of this, I forgot to increase the size of my fonts and stuff, so the first part of this stream was unwatchable, unfortunately. I mean, unless you're on a computer monitor, but that's okay. The fun stuff will happen next stream. This is a lot of this is just set up for the concatenation stuff, so. So I think what's happening here is we did see that. So our result is this whole thing, but then, yeah. The logic here is not great, so we only care if it ends up in the thing. We only care. This is annoying. So, because this is just peeking. If the peek contains a concat, that's fine, but it should not if this next chunk that we peeked is not part of our thing, so if here's what we're gonna do. We're gonna say, since we peek ahead, that might change our concat status even if that chunk isn't included in our result. So store it here and reset if we have to. B32 actually contains concat. It's false. We'll do this. This equals contains concat. And then here, if not that, contains concat equals actually contains concat. Hey, look at that, it's gone. Great. Okay, cool. So that's a little stupid. I don't really like that, but peeking, unfortunately, changes our concat status even if we don't intend on using the result. So if we notice that we're gonna throw it away, reset our concat status. Okay. So there we go. I'm printing out all the identifiers that have concat tokens in them. If I go back here and make another one, so like int new val equals, I don't know. We'll say new concat val. There we go. We have a new one. Great. That's fantastic. That's really good. So next time we do these two things. The node names now include the full concat directive, so it's up to the snippet code gen to figure out what it has to do. And also, we need to parse this as a new type of node that is a reference to a snippet parameter, which the parser should be able to, at parse time, just hook up, right? requires new Lexer token type 2, which I think it does. It'll be well, it might be actually yeah, it'll be one of these. Yes. Okay. Great. I'm gonna call that a success. Even though I wasted a lot of time on some goofy stuff, but it's been a while. I haven't streamed in a while, so you know what? That's okay. So I will probably be streaming tomorrow as well. Trying to get back into this. I'm getting very close now to where I want to be. Sorry again for the first half of this VOD being more than half, being so tiny. Anyone who's keeping up with the VODs, I apologize. Won't happen again. Okay. Yeah, I'm gonna call that for the night. It's getting late. Hope everyone had a good Thanksgiving, if you celebrate Thanksgiving. And yeah, I will catch you guys hopefully tomorrow. Talk to you later.